Alright, time to check back in here. Laid down all the resistors for which I had the correct resistors, and so there was a mistake in the order. I only had two 33 kilo ohms resistors, so I've marked that on my spreadsheet. I'm going to do that in my next mouse order. I think if you get deep enough into this hobby, it just becomes like a regular thing. I know there's like $8 shipping, but there is so much there that it makes sense. And in fact, I just got this adapter for my oscilloscope. It's manufactured by Pomona, and it is a BNC to dual banana adapter, so that I can plug banana cables directly into my oscilloscope from the Buchla modules. So a great tool, like specifically for testing these. And because of the way that I laid this all down here, it might be hard to just nail one leg of the resistor down before soldering. But we'll see how well I do at that. I think I could have done more. I could have tacked these down more regularly. All right. Lessons for next time. So, got tape all over this, holding all these resistors down. If we flip this over, it's hard to see from that angle, but from this angle, you can see that it's a little forest of resistor leads. And so, I'm gonna work, I think, from this side to the far side of the panel. Purcell, again, wants to bring us a mouse. Thank you, buddy. Thank you. While this is heating up, I have my last bag of resistors here for this module to bag up and sort. I'm building a second one of these because I'm gonna sell one of them to finance the cost of the whole project. And so having these all sorted out, will make that next build super easy. I don't have to go searching through things. Thank you, buddy. Thank you. I would say that the going price for a fully built DIY project from someone else who's done quality work on that project is about twice the cost of materials. And that kind of is a good rule for figuring out, like if you wanted to buy, I have like the ARP 1601 clone. That's the sequencer that was sold with the ARP 2600. And so, if there's hundreds and hundreds of dollars in materials, something like that, it's gonna go for like, I forget exactly what, but like $1,000. And as you can see, the alternative is doing very labor-intensive work that has a risk of you can screw things up, and easily you can just like rip pads out. And I think a lot of people have that experience doing DIY. You don't want to start with something like this where the PCB is $150, $200. It's really steep. You want to start with like something fairly simple. I think the Barton musical circuits is a great place to start because they're just like very simple, designs. Some of the initial ones I did like a quad VCA as my first project, and you get a taste of like what wiring looks like. Great stuff, and like I think even his philosophy is like, yeah, use data, like build this cheaply. Like he'll sell panels that don't have any prints on them that are just like cut, just hand drilled aluminum panels. And at the same time, his modules, people have adapted them into 5U, which is also a pretty labor intensive DIY format for the most part these days. Right. I'm gonna clean this a little bit with this solder. There's flux in the solder. I'm gonna open the window. So I'm just double checking that things are like seated here well. And let's start here. So you can go on the internet and Google kind of what you want these to look like. There is such a thing as too little solder. There is such a thing as too much solder. I'm looking for like a nice little teepee, I guess. I don't know what that shape. Cones. Cone is the shape that I'm thinking of. So nice little cones. And though that cone kind of indicates to you that the solder's flowed through into the hole for the pad. So I'm gonna start here. Take these off. Okay, and I know just from the shape that these leads over on this side, that's the opposite lead for the resistors I just stuck down with solder. So let's see what we can do here. One thing you can do at this step too, when just one of the legs is held down by solder, is you can push things, snap them into place by pushing them and holding the soldering iron to the remaining solder. I will note that the resistors get extremely hot, so be forewarned. I just burned my finger a little bit. This also being the reason that we want to nail down one of the legs before the other, is that we can just like verify that they look how we want them to look before we solder it down. Zoom, I'm going to turn off the display capture, and I'm going to move this camera here. All right, and take this and put it over there. Cool. Let's see what you can kind of see with this angle here. I'm gonna need this. So let's do some more of these. kind of shows the downsides of this approach. It's becoming very difficult to reach anything beyond this first row. And so what I'm going to do is I'm just going to take this up. And need some more tension there to assess that these look how they should. And again, this level of attention to detail, I think, definitely not necessary for just building. If your goal is just to build instruments, and you don't, maybe you're like not in it for the DIY, which I think is how I actually started. It seems like fairly interesting, but like I wanted to build a system. I wanted to have a system that was, the modules that I was looking at from IntelliGel, and I had like a skiff case where like it was out of my price range, and so the thought of starting to DIY cases and DIY modules. I'm going to tell you, ultimately, it probably was more expensive to DIY a lot of stuff. Definitely like worth your while to buy stuff from manufacturers. But, I think you can get to a place with the hobby where it's, for me as like a professional programmer, it's the same, kind of like hits the same spot, but there's no computer screen involved, unless I'm on Twitch. So that kind of it's satisfying like intellectually, but also there's this element that's like knitting or cross stitching or something, just really satisfying, and just fun to. It's like adult Legos with 800-degree soldering irons and. Just earlier, I burnt my finger on the desoldering gun. I thought it was off, and my finger tapped the nozzle, and it was, I guess, like as you'd kind of imagine, extremely hot, just like wildly hot. And I wonder if you can see my cat is really, he gets the mouse in his mouth, and he meows really loudly. I don't know what he wants me to do with the mouse. I don't want to play fetch because it looks like I don't appreciate the mouse. Sometimes I pretend to eat it. Thank you, buddy. It's back. I think he might be jealous of the attention that I'm giving to the computer, though, and the circuitry, because this is the second time in the stream he's brought me. I need to replace this mouse. This mouse is feeling like I know it's his favorite. He needs a new one. One thing I was going to mention here, if you you can see this kind of black, this wet look around the soldered pads. That's the flux that helps when you're soldering things. But in this case, because it's water soluble solder, like you shouldn't leave it on the circuit board. It can cause problems. And and again, we're gonna wash that off with demineralized water. Which there's like. I'm not 100%. I believe ionized water can like work fairly well. I think it's like sufficient. If I'm remembering this correctly, demineralized water is like has even fewer minerals than ionized water. Yeah, so there, like it wasn't fully seated. Personally, you should get off. You should get off, personally. This is not safe for you right now. Personally, you gotta get up. You gotta get off. You gotta get off. Personally. Good boy. Giving him some pats. The resistor wasn't fully seated in its little spot, so I held the soldering iron to the leg that's currently nailed down by solder and just pushed it back into place. So I'm gonna flip it over, make sure it looks right, and then solder on the other leg. And cut both those leads. No parts for you, Birdie. Birdie. My cats are very inquisitive right now. All right. Tapping down one leg, making sure it's seated. Let's see where these. I'm good. Birdie, you gotta stop. Birdie really wants to eat the cardboard boxes. I may have to give her one at some point. Alright, before I do this section, I'm just gonna try to do all of these. So I'm gonna take a look at this section. Look at what we're dealing with. These look here, and you can see like the only footprints that are left unfilled are there in that little tiny section of the capacitors. These are cheap side cutters. I got them on Amazon. This brand, CHP, made in Italy, it says. They're okay. I feel like that's a tool where I might treat myself and get like a fancy one. But yeah, I think tools are one area where having the right tool really helps. And so, like, you know, you can do damage to circuit boards and can make it very, very, very difficult to fix it once it's broken. Having something like a temperature-controlled soldering iron really helps. So this soldering iron is the Weller WTCPT. It is temperature-controlled, and the temperature that for the iron that's in there is exactly the temperature at which this blend of solder melts. And so earlier I mentioned that there is such a thing as like contemporary lead-free solder, which is what people use commercially in the United States, and it has a higher melting point. So this soldering iron actually wouldn't be able to melt that. I would have to switch tips. And one of the advantages of having that lower temperature is it's harder to damage the board, which though made of a pretty strong material. It's like it's 800 degrees. It's very easy to apply too much heat and then melt something off. Yeah, and that's I think one area where like I've had some circuit boards with like cheap solder masks that like and just a like cheap manufacturer that were fell apart when I was trying to do like rework them, but a good high quality circuit board can be replaced, and long ago electronics weren't meant to be discarded at the end of 2 years. And yeah, there's something nice about that. Ooh, these are looking good. This one almost had too much solder, so the shape was kind of bulbous versus convex. Well, convex cone is what we want. Also for solder with lead in it, you want it to look shiny. The opposite for lead-free solder, which looks matte when it's correctly a part is like correctly soldered in. These two can be soldered in. Yeah, I think next time I will at least tack down one leg as I'm going through all of them. I think that would have been advantageous. I don't know. I feel like your technique and process can kind of change depending on the project you're working on, how complicated it is, what helps you build the way you want to build, and what doesn't. I was just thinking about that. It's a video on YouTube. YouTube like soldering techniques, and there's a YouTube video about drag soldering, like super tiny integrated circuits, which have rows of pins on all the corners, and just how friends have mentioned that to me. I mean, it's a pitch for a like training service, obviously, of this like just hyper impressive feat of drag soldering a small chip. I mean, I don't know, maybe lots of people can do it, but I don't think anyone. I haven't read about anyone but people who are ex-electronics professionals in the synth DIY community doing it, maybe. Which there are. Paul Schreiber comes to mind, Dave Brown. I think it's Paul Schreiber. Yeah, of synthesis technology, who designed cell phones, I think. I think Dave Brown fixed things at Tektronix, which was an analog electronics company. So, you can go on the web and especially on Facebook groups. Like Paul Schreiber's like always talking to people, and they have great wisdom on a lot of these kinds of topics. And and so just making slow but steady progress across the board. I'm heating at the base of the leg in the pad and just making sure that it, I see it like flow down into the hole and a little bit up the lead. And then it kind of flows around the pad. And so you can kind of see it. I mean, there's this wicking thing that you want to happen, where it's kind of being wicked into the hole, and that's what creates this kind of convex cone shape. And let's see where we're at with those. Yeah, not my favorite way to do this. I think definitely gonna switch it up next time. This is not. I live in Brooklyn, so sometimes it's loud outside. If you heard someone driven by with music. I can just actually tap down everything that's left on this half, this top half of the two voltage processing halves, and so that'll allow me to kind of go down like this, like some aren't fully tapped down. Let's go right here. So now's a good chance to find any of them that aren't kind of fully flush against the board. You know, and again, this is like is more about aesthetics than anything else right now, but you know, the format is an excuse to just like truly bring your A game in terms of, you know, sourcing the exact parts you want to source. And I perhaps this is obsessive, but I went on McMaster Car, which is a I mean, they supply like a lot of different industrial products, but in particular they have very good screws. And so if you want a screw with M3 threading that's 8 millimeters long, done in stainless steel with like a specific Phillips head, you get that from McMaster Car. And so that's where I got the exact case panel screws that I have in my Euro rack that I wanted. And in Buchla modules, there are countersunk screws that hold the module against the PCB. And so I wanted those to be stainless steel, and so I bought the fancy stainless steel screws from McMaster Car. And they're such like a commercial vendor that they won't even quote you shipping on their site. They just say we'll charge you like what we can do, and it's actually always been reasonable for me and shipped like shockingly quick. It's like a lot of these companies that you encounter doing this kind of electronics work basically mostly exist for, you know, the commercial electronics world. And so we'll remove these resistor leads. I'm just looking at these footprints for the potentiometers. It's just super exciting. Yeah, I think it's nice to have a board that's like PCB that itself is really high quality, like this gold plating and the great solder mask. I personally really like that product. And I loathe white solder mask with all my heart. And unfortunately, I have some Modular Addict is one of the companies that really likes to do white solder mask, and I just think it looks gross. And unfortunately, I have a Buchla 158 that I built from the Laza Siente Buchla, you know, the Buchla, this Buchla 100 cloning project. And so Buchla 100 modules will fit in Buchla cases. And they just depend on, I think they like this one just uses the positive 15 volts, whereas a Buchla 200 case offers negative 15 volts, 5 volts, and sometimes 12 volts. But the PCB is white, and I find this deeply upsetting. I would rebuild it if I could get a black PCB of it. I'd rebuild it. I know it's just super neurotic. Okay, so we have the top half done. Just kind of feeling behind the resistors up here that I'm going to work on, that they are that the tape is going to flush against the panel. Sorry, against the PCB. Just a couple seconds for these. So the process that I like to use to clean up all this flux and to clean up the board for this is I have basically like a brush that is like these nylon bristles. And so nylon obviously softer than the solder mask, softer than metal. It's not going to scratch the board, and I get the deionized water, rub it off with the use the brush, rub off all the flux, and then leave my oven open at 100 at its lowest setting, which is 170 degrees. You know, you can touch whatever's inside it, and then after hand drying it, I leave it in there until all of the moisture has evaporated. When exactly that is, I'm not 100% sure, but that'll just like make sure that any water that's gotten into nooks and crevices like definitely dries out. Even though it'll probably dry out anyway. And again, there's like demineralized. There's nothing to condense on the surface. Just to be doubly sure. Okay, I'm feeling great about this. Yeah, feeling really good about how this is looking. Everything over here looks good, so I'm going to tack down. That's the word I've been looking for this entire session, is tack down. I kept saying tack down. I've been trying to learn from Dave Brown's page as much as possible, and he says, and this is where I got this actually the specific part number for the solder. I wanted the exact solder that he was using because the results on his page are, if you see it, I mean they're just like immaculate. And he says that he actually washes off the board every hour that he's soldering things down. So he did not use the technique that I just did of laying down all the resistors and soldering them all at once. So yeah, I think on the next board that I do, it'll probably be another 257 before I hit the 2 complex oscillators I'm going to build. I will try that technique. These are side cutters, not scissors. Yeah. Just thought I'd share that. And we're trying. Okay. Let's see those. We're able to clip with that edge, and it like lays flat against the panel. These are needle nose pliers that I was using. I think both these cost like $6 on Amazon or something. The pliers eventually kind of wear out, which is why I was thinking of replacing them with higher quality tools. This guy who makes extremely nice cases, I think Needham Woodworks, mentioned that he's using 70-year-old tools from Klein, so that has inspired me. I was like, all right, I will see which of my tools I can swap out. I'm just on such a rush for my desoldering gun, which I just didn't even think that technology allowed such a thing. Like I vaguely knew they were very useful, and like thought that you like might be able to pull out a full IC socket using one like relatively easily. Like an IC socket will fall out of the board. It's amazing. Checking these guys here. I'm gonna finish these up. Might get better lighting. This is probably pretty noisy. The video is probably fairly noisy. The second one doesn't feel as flush as I would like. Cool. Cut these two. And then tack them down. Just finish placing them. And so, yeah, I'm gonna go through and just tack down one leg for the ones that I can. Alright, so momentarily I should have resistors on this side. Tack down if my head is covering this board. Doesn't work on it. Alright, there you go. Just burned my finger. Wasn't paying attention. And it like immediately like can sear. Ugh. Okay, so this is a good example of one that needs to be actually two. I think this is not enough solder here, and I wasn't able to get it to move well without a little more solder there. I mean, the solder and the flux help transmit the heat also, and so there are some places where you can't really. It helps to add solder so that can transmit the heat throughout like whatever you're working on. Straight and straight. Okay. It's fun when thinking about modular synthesis, about this kind of like broader idea of like layers of abstraction, right? And so like in programming, there's this idea that you abstract away different layers of complexity. So I don't write the network code that it deals with like how one computer acts with another. I don't have to write that code. There are libraries that work on top of that, and then there are, that aggregate all those communications for the system, and there are libraries on top of that that say, here's how you do fetch requests in a browser, right? And so like that goes up and it goes all the way down. And so with modular synthesis, when you're using cables, you're working at one level of abstraction, but then you dive down into an individual module, and you have like, now your level of abstraction is how these little, even smaller pieces interact with each other. So, when you make a patch, you've made this whole giant crazy circuit, but you've done it at this, at this level of abstraction where you're just patching with cables. I won't lie, my finger does hurt quite a bit, to be honest. Okay. And luckily this module, in some ways actually it's like fairly simple. The part count isn't that high. It's laid out pretty simply. Wiring will be quite simple, which makes it you know, this is like the best kind of simple synth DIY project. If you asked, Loudest Warning is this guy who does these surge style modules, and he does them in the original style. This so-called like paper face, and so back in the day you would get pre-drilled aluminum and you would paper over it, I believe with your own design, and like laminate that on there, and that's how you made the front panel. Then you soldered all those circuits, and you literally wired different points on those circuit boards to all the front panel controls. So unlike this, where you can see that the front panel controls, I mean, sure, these will be wired, but they'll be like one simple wire. These are not wired. They're all 3 pins of this potentiometer are like actually just built into the board, and so there's no complex wiring needed, and that also is like the fun of building something in the Loudest Warning format. It's like a totally different kind of like tactile activity, where suddenly you're like working in 3 dimensions and trying to like figure out the best way to kind of organize your wiring, and like, you know, in the same way that I'm thinking about how to best solder in these resistors, and like how do I fucking make the perfect solder joint. You know, you end up doing the same thing with the wiring. You're like, all right, well, now I want to use like the right shrinking tubes. There's some word for this that I'm forgetting. Shrink wrap? Not shrink wrap. Heat shrink something. And then making sure all those connections look right, and like, you know, for one module that I'm building, I bought a bunch of chiclets, which take a pot that's in a similar format to this, and then add a little tiny kind of floating circuit board that you can wire stuff into. See how we are looking. Very good. Very good. Yeah, these 4 are done. Try to get that lined up for you guys. Alright, we're getting really close here. Let's see where we're at these. This is definitely needs to be reseated. Great. Let's see what that. No. I am going to. Try to use a little more insulation this time before I press down on it. Not what I want. Not what I want. There we go. Perfect. pin one lead down. Oh, that's the tape came off of that. And I'm gonna tack down this guy here. These guys here. So if I take this, tape off, I think all of them are, look like they're seated right. So we can now finish up these resistors, after which I will sign off for the night. So peace out. This one I think could be for a little bit. Great. Great. Oh no. My kid tried to jump up on the desk. Okay, so now I am just looking at the board to see that, to like, you know, just investigate everything, make sure I didn't miss any spots. I think it's like a much bigger problem with surface mount. Often when you're doing it by hand, you pin down one half of the resistor, then do a bunch of those, and then go back and do the other side. And I've seen this with other people's builds that they've sold commercially as well. You get a limited amount of connection just by virtue of the fact that the two pieces of metal are on top of each other when they're not soldered. And so that can cause these weird intermittent issues that are hard to debug. So that step of, if someone says a module is broken they bought online, the first thing I do to try to diagnose that is to just do like a visual inspection of every single pad and make sure that whoever is supposed to solder it actually soldered it. I mean, again, it's easy to miss because you might be testing for it and there's that intermittent connection between the resistor and the pad. Anyway, this looks just like super excited about this. This looks really good. I don't have a great way of bringing the video setup with me to the kitchen. Maybe I'll rinse the board here on the desk to show you guys what that looks like. So again, I'm gonna rinse the board here. I'm gonna use a brush to do it. In my oven is going to be open, set to 170, with a paper towel set down. Not paper towel, like a cloth towel set down. And after I rinse this and hand dry it, I will leave it there for a minute to dry even more. And if it were earlier in the evening, I would keep soldering, but it's getting a little late. So yeah, I'm gonna do that, leave that out to dry, put a picture of this on my Instagram, and yeah. And order the resistors that I don't have. All right. Yeah. So I think I've been saying demineralized water, which would be great if I had it, and I think would be superior to what I do have, which is distilled water. I think demineralized water is not a product that you can buy at your local grocery store, which is where it is. So it's very delicately, as I have a bunch of fucking electronics on my desk. So I've got the water. I'm gonna take the board out. I'm just sliding the board out from its little holder, and we had the masking tape I put down earlier, which helps it not scratch or anything. And so, I can get it to. I can kind of show you. There are these kind of shiny. This is not working. Yeah, I mean, you can see like little kind of black spots around. Kind of where. Yeah, you can't see this at all on my camera. Well, nonetheless, there are little black spots, and it doesn't look 100% clean. So I can actually submerge this guy. And yep, I'm putting it in water, and I'm using this nice little nylon brush so as not to scratch anything. Nothing has been soldered on this side of the board, so I don't have to clean the other side. But soon enough, we'll have to do both sides once I've soldered the like switch and LED on. So for now, I just do this side. I'm gonna take this. This is the forbidden water. Can't drink it. Take this. Take this. I'm gonna close this now. Fucking off my desk. All right. Just have a gross looking kitchen washcloth. We're gonna fucking hide that. But yeah, nice and soft, nice and gentle. You know, just kind of treating it like a non-stick pan. You don't want to. Okay, so mostly dried, so I need some work. All right, this is gonna go into my open oven at the lowest setting let it dry out. I'll have this board. There won't be any little black spots on the solder. It'll look really clean. Then next up on this board is going to be by height the IC sockets. I think those are as tall as the trimmers I'm going to install. Install those. Then install all the capacitors and the transistors, which are kind of like elevated off the board. And then, yeah, I might just start doing the front panel components. So we'll see.